All right, so in this video, we're going to just talk about general problem solving strategies for linear equations. And this basically is going to transcend from now until you're done doing application problems, which, let's be honest with you, even in daily life when you're no longer taking a math course, they still apply. All right. So when we go ahead and we talk about solving problems, all right, we always want to start with step one, which is going to be just understand the problem. All right. Now, normally what I like to say is no math. And what I mean by that is, I don't want to hear like a formula or something like that. I just want to know, like, what is the general idea here? If my name is John. So if John goes to the store and he buys twice as many pens as he does notebooks, and the number of markers he buys is going to be 3 times the number of notebooks that he has. I mean, that's a very complicated problem. To understand that, though, the only thing we gotta really ask yourself is what's happening. I'm just going to the store. I'm buying items. And if you think about that, that kind of already narrows down what we're doing. We're buying items. What are the items? Pens, notebooks, and markers. 3 different things. So you can start to see how, like, just by understanding the issue with no math involved, you already got a really good understanding of what's happening. Now, step 2, we always want to ask ourselves just 2 questions. The first question is going to be, what do we know? Okay? And then the second question will be, well, what do we don't know? Okay, now within this step, this is where you're going to be writing things down. All right, so you might write information down. You may draw a picture to help you think about it. You could even write a sentence with, math operations if you wanted to. Okay? You can maybe think of a formula or something you may need later on. I mean, there's a lot that goes into step 2. Step 2, I think, is one of the hardest steps, but it's also one of the most exciting steps because it gives you that second or that chance to slow yourself down, reread the problem, and think about what's happening. Step 3 is you want to make sense of steps 1 and 2. You want to formulate a plan. Now, perhaps maybe formulate is the wrong word because I don't want you thinking that we're going to be using a formula. The majority of the time, you're going to be creating your own equation here. All right? You're going to be creating your own equation. However, there will be times where you may use a formula like the Pythagorean theorem or the area of a rectangle or something like that. All right? Step 4, carry out your plan. In other words, once you formulate your plan from step 3, and step 3, all that information comes from is going to be step 2 with what do we know and what do we not know. Okay? So once we get to step 4, this is kind of like a downhill slope now. It's kind of like pushing the car all the way up to the top of the hill, and then you just let it roll downhill. You're going to be using all your math techniques to solve the problem. That's where the math techniques start kicking in. And then finally with step 5, okay, you want to ask yourself, does the answer make sense? And a good way to answer this question is, well, write a sentence. You should be able to write a sentence that describes your answer and how it applies back to the original problem. And this is just our general approach for solving any type of problem. In this case specifically, we're going to be looking at linear equations. So all of our variables are going to be raised to the first power. Okay? So let's look at our first problem. All right, now I'm going to be taking these problems directly from our text, so it's going to be we're going to keep it very consistent. So the sum of a number and 9 is 17. Find the number, okay? So step 1, let's just understand the problem. What are we doing? We are adding numbers. Notice very general, nothing specific. We're just adding numbers. Now, step 2, we're going to answer the first question. What do we know? Okay, what we know, we're adding two numbers. Okay, so how do we know that? Well, we have the sum of a number and 9. So we also know the second number. One of the numbers is 9. So we know that. We also know the total. The total of the two numbers is 17. And I think we've pretty much exhausted everything that we know. So the second half of step 2 would be, well, what do we not know? Well, that's pretty self-explanatory. We do not know, so we don't know one of the numbers. And as soon as we can identify that, what we're going to do is we're going to say, well, let's let x equal the first number. Okay? So now in step 3, this is we can go ahead and we can formulate a plan. We're going to be creating our own equation here. We know that we were, and I'm going to use my highlighter here. We know we're adding two numbers. One of the numbers is 9. The total has to be 17. And we don't know the first number. So what I'm going to write, and I'm going to really draw this example out. We know the first number plus the second number. So the first number plus the second number has to equal 17. The first number we called x. The second number was given to us. It is 9. So now we have x plus 9 equals 17, and there's our plan. Step 4. I'm just going to rewrite it. And we're going to carry out the plan. We're just going to let math do its thing. So I will subtract 9 from both sides. 17 minus 9 is going to be 8. So, step 5. Does the answer make sense? Well, you can check it if you wanted to. 8 plus 9 definitely equals 17 anywhere you go. Okay? So, notice I did my approach to this word problem, and maybe I didn't need to really do all this just for this one problem. Maybe I didn't have to do this, but I wanted you to see how this process works, okay? Because we got to get disciplined with this. We got to make sure that we're going through this process over and over and over again, okay? Once we get really comfortable with this, can we start to maybe speed up a little bit or maybe skip a step, which I do not recommend skipping anything. I'm a huge fan of just writing everything out. But it's the approach that we have to get comfortable with. And that's why we do not like word problems, because we try to move too fast. Stick to the approach. Let's look at another problem. Okay, so here's our next example. Pretty similar to the previous, definitely more intense though, okay? So one number is 14 less than another. If their sum is increased by 7, the result is 85. Find the numbers, okay? So step 1, let's just understand this. What are we doing? Adding numbers again. So 2 different problems, same exact idea. We're just adding numbers. How do I know that? Because it's saying their sum. Okay, so I know I'm adding numbers. More importantly, if you read the very last statement, it says find the number. So I know I'm adding multiple numbers here. So let's go with step 2. What do we know? Well, we know one number is 14 less than another. Okay? We also know the sum of both numbers is increased by 7. Now, that is a very powerful statement, because what that's saying is the first thing you got to do is find the sum. Then the second thing you need to do is increase it by 7, which means in order for me to force somebody to do something first, I got to use parentheses, because remember, the order of operation says you do things inside parentheses first. So with this one statement right here, the sum of both numbers is increased by 7. I'm going to have two numbers on the inside. So the first number, and I'm going to have to add the second number first. Then I add 7 on the outside of it. Okay? Very, very, very powerful statement. And I think the last thing we know, the result is 85. So it looks like I already kind of got my plan going on here. So let's answer the other question. What do we not know? What is that thing that we're missing here? Well, we don't know one of the numbers. Let me write the words one of. We don't know one of the numbers. Okay? We know the other number. Let me highlight it. See, we definitely know the second number, because the second number is 14 less than another number. So if I knew the first one, I know the second number is 14 less. Okay? And just by saying that, hopefully now you're starting to see step 3, which is our plan. We know our first number plus the second number has to be in parentheses. We're going to add 7 to that sum, and that has to equal 85. The thing that we really don't know, so I'm going to write this in red, we're going to let x equal that first number, which means by default, I can go ahead and start to fill in this little equation that we've created. Parenthesis, the first number is x, plus, now that second number, let me scroll up here so we can see it again. The second number is 14 less than another. So this second number is going to be x minus 14. Then I need to sum them together and add 7 to it. And that has to total 85. So now that we have our plan, step 4 is just carry out the plan. So I'm going to go ahead and just rewrite it. Now I'm going to do the work inside the parentheses first. X plus x is going to be 2x minus 14 plus 7 equals 85. Now remember, technically there's a 1 out in front of this parenthesis, so we'd have to distribute that, but it doesn't change anything. So this is just going to give me 2x minus 14 plus 7 equals 85. Now I look on the left-hand side, I can definitely combine. 2x minus 7 equals 85. I'm going to add 7 to both sides of my equation to isolate the variable term. So that's going to give me 2x equals 92. And then finally, I would divide both sides by the coefficient of the variable term to give me x equals 46. So in step 5, remember, you got to make sense of this. The first number is 46, which means by default, the second number is 46 minus 14, which equals 32. Because remember, they said find the numbers, plural, so we need both of them. So we got 46 and 32. Once again, completely different problem, same exact approach. Okay, let's look at another example. Okay, so this last one right here is one of my favorites because it deals with this thing. You can see this word in here, consecutive. All right, so let's go ahead. Let's read the problem. Find 3 consecutive odd integers whose sum is negative 267. So step 1, what are we doing? We're adding. So we are just adding 3 consecutive odd integers. Okay. So maybe that's a little bit too specific. Maybe I could have just stopped at the word adding and called it a day. Step 2. What do we know? Well, I got to be honest with you. We don't really know a lot. We know that they're consecutive odd integers. And we also know the sum total is negative 267. What do we not know? Okay, well, we don't know the numbers. So we don't know our first number. Let me write out the word number. So we don't know our first number. We don't know our second number. And we don't know our third number. Okay, so those are things we don't know. All right, so what we can do is we can start to think about this here. All right, so here's step 3. Notice I didn't really assign a variable yet or anything like that. So here's step 3. We need to formulate a plan. Okay, so excuse me. So when we go ahead and formulate a plan, we got to go back to what we know. We know these numbers are consecutive odd. Now consecutive I just keep it like this. Consecutive first means in order. So in other words, if your first odd number is 3, then your second odd number has to be 5, and then your next odd number has to be 7. Okay? Let me do another example of that. If your first odd number is 55, then your next consecutive odd number has to be 57, and then the one after that has to be 59. So they got to be in order. But here's the thing. We don't know the first number. And when we don't know something in math, we're going to let x equal the first number. We're going to assign it a variable. Okay? So if we go back to this 3, 5, 7 or the 55, 57, 59, this consecutive order of odd numbers, all you got to do is ask yourself, well, if you start at 3, how do you get to 5? You add 2. If you start at 55, how do you get to 57? You add 2. Therefore, if x is going to be our first number, well, if I add 2 to that, that's going to give me my second number. Okay? Now, if you start at 3, how do you get to 7? Well, you add 4. If you think about it, it's going to be 3 plus 2 plus 2 more. 3 plus 2 gets you to 5, and then 5 plus 2 gets you to 7. All right? So our third consecutive odd integer will be x plus 4. And now that we know our 3 numbers, we know that these have to total to negative 267. So x plus 2, which is our second number, plus x plus 4, which is our third number, has to equal negative 267. And right here is our own equation that we created for step 3. Step 4, I'm just going to rewrite it because we're going to go ahead and solve it. Now just remember, you got to be careful. And you also got to remember that the problem wants the 3 numbers, not just one of them. So let's go ahead and let's solve this. First thing, I know those parentheses. I got to distribute a positive 1, but that doesn't change anything. So I can just go ahead and erase them. Now I'm just going to group all my like terms. So I'm going to have 3x plus 6 equals negative 267. Now I will subtract 6 from both sides. So negative 267 minus 6 is going to be negative 273. And then finally, I will divide both sides by the number in front of the variable to give me x equals negative 91. Step 5, let's go ahead and make sense of it. So our first number, x equals negative 91. Our second number has to be negative 91 plus 2, which is going to be, if you now this is where you got to be careful, okay? You got to be careful because you got to actually think about this. Negative 91 plus 2 is going to be negative 89. And then our third number is going to be negative 91 plus 4, which is going to be negative 87. And those are 3 consecutive odd integers whose total will give you negative 267. All right, so I hope this helped. And in the next video, we're going to be talking about percent problems and then mixture problems.